Looking back at the edge of a black hole, you'll see 100 versions of yourself. This is not magic. It is a photon sphere. In 15 seconds, even light will be unable to escape your eyes. Let's talk about a tough topic today. What would happen if you were thrown into a black hole? This time, it's not science fiction. It is indeed speculation based on hard physics. Before you throw me in, let's briefly review what a black hole is. Even Einstein, that old man, back then, he described black holes as divide the emperor by O. He didn't believe in this stuff at all. It really exists in our universe. But you see, humans actually found it. When those are particularly huge, when exceptionally dense clusters of stars reach the end of their lives, they will undergo a major transformation. He shrunk himself, nothing left. What he created is called the starting point, a mysterious point in space-time. It is said to have infinite density. Therefore, it possesses infinite gravitational force. General relativity gave us a revolutionary idea. Gravity is not a force acting on an object. He is merely a time in space-time, the result of the object bending due to its own mass. He completely explained our Earth. How does it orbit the Sun? And the planets are like those surrounding their own home. Rotation, there is no solid black surface inside a black hole. The hidden starting points are simply too dense. It severely distorted space-time. It formed a deep well with vertical walls. In 1939, Einstein, he even published a paper on the subject. The idea that stars can be the starting point for a cosmic process is unreliable. It wouldn't happen in our universe. What a coincidence, it happened in the same year. Oppenheimer, that's the famous Oppenheimer, and physicist Hartland Snyder, they co-authored a paper, Predict, stars may indeed be under their own gravity, shrinking into a black hole. Let's talk about what would happen if you were thrown into a black hole. What will happen? The most amazing thing about black holes is he can turn anything into him, no matter you are a star, planets or tiny people like us, as long as it is compressed to a level suitable for Schwarz. Within the radius, they can all become black holes. German physicist Karl Schwarzschild, he was the first to discover the exact equation of Einstein's factory equation. The discovery by those who understood it was both simple and beautiful. Take our sun, for example. If all his mass were compressed into one, a sphere with a radius of only 3 kilometers, he became a black hole. What about Earth? He will become a creature with a radius of approximately 9, a sphere of millimeters. It's about the size of a marble. If we humans wanted to become black holes, that would be terrible. It would have to be compressed to a size much smaller than a proton. Incredible small. But if it could really become that small, we'll become black holes. Which black hole should we throw you into? I think it's time to throw you into a black hole. But which one should we choose? We can choose a smaller one, but that's so boring. Let's choose a bigger one. Some black hole event worlds, larger than our entire solar system. That would be billions of solar masses. That's way too exaggerated. Why not choose one that's closer to home? Sagittarius A*, the supermassive black hole located at the center of our Milky Way galaxy. You're running around it. It is still us humans, one of only 2 black holes ever photographed. Now let's set up the scene. Let's say you and I fly there. Park the spaceship at a distance of 10,000 meters from the world, a place of 100 million meters. We're going to send you to the black hole. When you free fall, I will stay on the spaceship to observe. But this is the key point. General relativity tells us, people near black holes, the experience may be completely different from others. Because black holes warp space-time so drastically, this effect was demonstrated in Interstellar. To record time, will give you a special watch. It can display from your perspective, my perspective from the spaceship, how much time has passed since they parted. Let's set the watches together. Now you can begin your black hole journey. When your journey begins, you will see the black hole in the distance, rapidly devouring matter. The scene was spectacular. The material is heated to extremely high temperatures due to friction. If this scene simulate on a regular laptop, it will take more than 10 years. In reality, the disk would be a bright blue or even white. But in this simulation, he was made orange. This makes it easier for us to observe. Only 30 minutes have passed since you first checked your watch. You've only completed 0.1% of the journey to the world. So far, I only gained 11 seconds more than you on the spaceship. The time difference isn't too exaggerated. We're now closer to the black hole. Space-time warping around black holes, creating all sorts of strange visual effects. Light emitted from black holes from the side or even behind. It was bent before it even reached your eyes. Let's take another look at the time. You have been gone for 2 hours. 1.4% of the journey has been completed. I'm currently on the spaceship, 44 seconds ahead of you. This time difference is a bit worrying, but it's not too outrageous. The dark area in the middle of the shadow of a black hole, it seems to be growing faster than we expected. This is all due to the gravitational lensing effect. The light that would have passed by you, they've all bent up to your retina. A long time passed. You finally checked your watch again. This sight really gave us a fright. From your perspective, you left approximately 12 hours ago. But for me, on the spaceship, I have observed you drifting towards the black hole. It's been almost 15.5 hours. We're very close to a black hole now. Things are about to get very strange. Before you reach the irregular point, you will arrive at a strange and magical place. If you get frozen in this special place, in time, then look around. That sight will definitely amaze you. You have arrived at the photon sphere. This is the most, in the known universe, one of the strange places. In the region of the photon sphere, gravity is just in balance. This allows photons to orbit around a black hole. Light is not emitted or reflected by matter. Instead, the photon itself is trapped in orbit. If this beam of light moves tangentially to the black hole, he can then operate in orbit. But what if the path changes even slightly? Photons either fall into a black hole or fly into space. Under these specific conditions, if you only freeze at the photon sphere and look around, you will see your own mirror image with your back to yourself. You will see multiple copies of the back of your head condensing. Looking at space, you are actually looking at yourself, just like standing next to you. No technology required at all. It's all due to the distortion of space-time itself. As you continue your journey, you are very close to the world. We've now passed the photon sphere. Black holes are taking up an increasingly larger portion of your field of vision. It feels like you're being swallowed by darkness. This is because darkness is distorted around you. The back of the black hole's shadow, showing both the front and side views. And in flat space-time, the part that is usually visible to you. You have been gone for 13 hours. In 24 minutes, you will be crossing the world. Can be taken from the spaceship. I have been observing your journey. It's been almost 20 hours. Another 18 minutes passed. You check the watch again. I've been observing you for almost 40 hours now. For you, the final 18 minutes. It lasted for a full 18 hours for me. The final moment arrived. 6 more minutes. You are about to pass through the world of the black hole. Close your eyes. Take a deep breath. Check the watch. But he seems to be broken. He showed, I have been watching you fall for an infinite amount of time. But he wasn't bad. Physics is truly amazing. I spent decades on the spaceship, watching you slowly approach the world. Finally, I saw you become Hongyi. This means I need an infrared telescope to see you. I will never see you cross the world, even if I could live forever. For you, the final 6 minutes. For me, it lasted forever on the spaceship. It sounds like science fiction, like a daydream, but he is absolutely true. It came directly from Einstein's equations. You are now in the world. What happens inside a black hole? Strangely, you can hardly notice it. When did I travel through the world? You can also look outwards to the universe, seeing distant stars. They even saw a spaceship floating in space. But all those lights are just like you. Everyone has to head towards the starting point. You have passed the point of no return. That point with infinite density. Our physical laws have all collapsed. Time has stopped. If you want to escape the gravitational pull of the starting point, you have to be faster than the speed of light. We all know that's impossible. A common misconception is, if you look outward at the universe, strong time dilation effect, it will show you the entire future of the universe. History unfolds before our eyes, but this is not true at all, because of aberrations. As you approach the starting point, you will see the outer universe compressed into a tiny dot. Fine rings. Finally, when you are close enough to the starting point, your feet will be stretched in front. Your body in Italy, it is stretched during the process of surface formation. You and the black hole become one, drifting together in the universe until eternity. Just thinking about that process sends chills down my spine. But I couldn't resist wanting to find out more. Black holes, these mysterious celestial bodies, it's something we both love and fear.